What's going on, everyone? My name is Johnny Bandon, and I'm your CCNA instructor for this CCNA video series. And in this video, we're continuing with our wireless section, going over now the terminology and different topologies we have in our wireless LAN or our Wi-Fi network. So we're going to start off this video by going over just the very basics and going to work our way back up. So we're going to start with an ad hoc network. So what is an ad hoc network? Well, imagine you are somewhere without infrastructure. Meaning you and your buddy had to go out to the middle of nowhere, set something up with your computers, and you forgot the Cat5 cable. Or you and your buddy don't have NICs on your laptops, you got those super thin MacBooks. Well, how are we going to be able to share data with each other if we don't have a medium to do it? Maybe we don't have a flash drive. One thing that we can create using Wi-Fi or RF is an ad hoc network. So this is going to be a peer-to-peer network created on the fly without that need for any centralized hardware to control our Wi-Fi network. So as you can see here in this little diagram here, we have two computers. Let's say this is PC2, PC1. They decided to set up an ad hoc network. So PC1 and PC2 both agree that, hey, we're going to transmit data on the 2.4 gigahertz range, and we're going to connect to each other with this name, SSID name equals Lost Boys, right? Because they're lost in the woods and they got to share some data with each other. And they're going to agree on the parameters, and now they're going to form that peer-to-peer network. So you can see that their radiation patterns here, they actually want to connect like this. That's how they actually connect to each other. Typically, when you see a network diagram like this and there's like a computer in the middle, you start talking about roaming, RSSI, but with an ad hoc network, that's what you want. And if you wanted to add a third device in here, this would not work when PC3 had to communicate to PC1. You would have to go here and here. If you wanted to add a third device in that ad hoc network, his or her radiation pattern would have to all meet up at some point, right? So this is what we call a ad hoc network. We're not relying on any central network or router to facilitate communication. Essentially, imagine this is just like plugging in a Cat5 cable to each other, except we're using RF or Wi-Fi signals. And of course, this does depend on whether your computers have enough power to send a signal strong enough out. They usually do. Like, you can set up hotspots on your computers, and they usually reach pretty good. Obviously not going to be as much range and power as an actual dedicated access point, but it'll work. This is not a scalable solution, meaning that we only do this when we have to, when it's absolutely necessary. You know, if we're in an environment, small business, medium-sized business, we're not going to be like, hey, you over there in Office 2.1, I'm in Office 2.3. Let's up an ad hoc network to share this accounting file. It's not, that's never going to happen, right? We just kind of build our base up, right? Going over what an ad hoc network is. And that term you'll see in other realms of IT. When you're talking Ansible, they go over ad hoc commands, just like one-off commands. So the term is good to know as far as you being a technician. And then we have IBSS. This stands for, I'll write it down here, Independent Basic Service Set. So this is kind of synonymous with ad hoc, except it's more of a Wi-Fi term specifically, right? Where ad hoc, like I was telling you, you could have multiple definitions for the term ad hoc or use it in multiple different disciplines. If someone says an independent basic service set, that means they're creating a peer-to-peer wireless network with no access point. Essentially meaning your device is setting up a wireless network with one other device, point-to-point, peer-to-peer. That's an independent basic service set. And we're going to go over in the next few slides basic service sets. So a BSS is a group of devices that communicates with the same access point or within the same range of the device emitting an RF signal. So what is a BSS? That is going to be the signal range of your access point. And all the devices that fall within that range and connect to that access point, that's going to be the basic service set. So BSS stands for Basic service set. And this is going to be the basic building blocks of a Wi-Fi network. You know, why? Because it just describes essentially an area that Wi-Fi enabled endpoints communicate to the access point, right? That's all it's saying. It's saying this basic service set right here for SSID home falls within this range, whatever that range may be. Now, if you come down here and kind of look at this network, well, what's going on here? So this is a basic service set, this oval, and this is a basic service set. They're different. Meaning that even if these computers, let's say this is PC1, this is PC2, even if they're connecting to the same SSID, let's say it's accounting VLAN, that's the name, this computer is not part of this computer's basic service set because we're talking just access point and the RF. Same network? Yes. Same access to resources? Yes. But are they in the same basic service set? No. That only describes the RF or this Wi-Fi signal in range acting or connecting to one access point. Now, what about this little guy here, PC3? Let's say he sits in between both these signal ranges. Well, which basic service set is he going to be a part of now? Now, a lot of this depends on how you deploy a network. We're going to get into something called ESS, extended service set, where these computers can roam between these two access points, and you're not going to see any degradation. But when does PC3 connect to this access point or this access point? If they're the same, if they're being advertised as the same SSID, how does he know which access point to actually send RF signals to and receive RF signals? That's going to be based off something called the RSSI. That's the received signal strength indicator. And whichever signal is stronger, that's the one this computer is going to connect to. And that's going to all be done within that Wi-Fi NIC. It's going to determine which access point it should connect to based off that RSSI if you're telling that computer to connect to the accounting VLAN. And we're going to get into these advanced terminologies in just a second. Okay, and then infrastructure mode. So this is just another Wi-Fi terminology that describes any wireless network that uses an access point to connect devices. So when we go over these ad hoc and IBSS networks, we're simply just talking about, the Wi-Fi oval here, the Wi-Fi signal range. That's all we're talking about. So a basic service set is just the range of that Wi-Fi signal being emitted. And that's why it says here a BSS can either be an infrastructure or ad hoc wireless network. Because no matter what architecture you deploy, no matter what AP modes you have, you're always going to have a BSS because there's always going to be Wi-Fi signal emitted within a certain range. So when I first started learning wireless, that's one of the things the hurdles I had to jump through is understanding the differences in these terms when you're like, aren't you just describing basic stuff or the same things? But it's different. Infrastructure mode is saying that there is an access point to connect devices. There is a central hub. There is some piece of hardware there that computers have to connect to reach out to the internet. So this is not ad hoc, right? This is infrastructure mode. And this infrastructure mode is kind of that umbrella term. We have a lot of different architectures. We have lightweight mode for our access points. We have autonomous mode for our access points. And these describe different ways to deploy and manage access points, but they're all fall under infrastructure mode, right? Because we have hardware that is the central processor, the brain for our Wi-Fi network. That's what infrastructure mode means. Essentially, we are setting up devices, infrastructure, to have some sort of centralized way to manage and control the network traffic from our Wi-Fi enabled devices. So complete opposite from ad hoc, where you just have endpoints talking to each other, right? There's no centralized hardware. Okay, so then we have BSA. So BSA is another term that describes the coverage area of an access point or wireless network. So you may be wondering, okay, well, how does this differ from BSS? Well, BSS just describes the range, not the actual coverage. And you may be thinking, well, come on, man, that doesn't make a lot of sense. Are we just reusing terms? And, BSA and BSS can be synonymous in some ways. Where you want to talk about the differences in the BSA, the basic service area, this can describe like a mesh of access points and all their BSAs combined. Whereas BSS, it's nope, just one access point and just its range. So that's how you can kind of describe or use these terms to describe different things. So the BSA, the basic service area, is going to depend a lot on the strength of that access point signal. So kind of what I drew here for you guys is an omni and then a unidirectional antenna. So this is called, this is a unidirectional antenna and it's a parabolic one. It's what you see on ground earth terminals reaching out to satellites or antennas reaching out to satellites. It was what my day job was in the military for a little bit, satellite communications. And these parabolic antennas are essentially really overpowered unidirectional antennas. And this is kind of what it looks like, its radiation pattern. If you were to put this on like a graph, what we see here is like the basic service area. You see the strength right down the middle here, and then you see it getting weaker as the RF kind of emits out from this directional power. And then with an omnidirectional antenna, you see that the closer you are to the antenna within this 360 degrees, right? Or not like that. I should put a 0 up there. If you have like 0, 90, 180, 270, and then, 360, right? The closer you are, right, no matter what you're at, in a perfect world, meaning there's no interference on this omnidirectional antenna, the closer you are, the better your signal strength is going to be. And the farther away you get, whether you're at this 180 range, 180 degrees on like this circle graph, or you're at 340 degrees, the farther away or the distance, you're going to get weaker signal. Whereas with the unidirectional, depending on, like if we did an axis here, if you're sitting over here, you're not going to get any signal. But if you're sitting right here, right in the middle of that BSA, you're going to get a lot of signal. So it kind of just describes the strength and the coverage area of an access point or an entire network. So if we're setting up multiple access points in an office, we can use like a heat map to see our BSA of the entire wireless network. Where are we getting coverage? Where are our weak spots? And where can we decide what kind of antennas we need to mitigate those weak spots or to remediate those weak spots? Okay, then SSID. So another important Wi-Fi term that I think is probably one of the most common ones. People on the street know what an SSID is for the most part. And that's the unique name given to a wireless network. There's some parameters I want to talk about the SSID. That is 32 characters in length. 32 characters. If we're talking Cisco, that's what Cisco puts out. And it's used to identify and differentiate between multiple wireless networks. So you see here, this is like the home router, let's say, for example. And these computers all connect to a Wi-Fi network or a wireless network based off the SSID. So even if I go to my own computer here and I bring up like my network connections, look at all the SSIDs within my range to connect to. But my computer connects to Trepa Technologies IoT or home. I got 2 Wi-Fi adapters on here. And that's the ones it remembers to connect to based off the SSID. So Trepa Technologies IoT is the SSID name that I configured for my home wireless network. So typically in just a standard home network, you'll see something like this, my SSID, and that may be for your 2.4 gigahertz range. This is your 5, and this is a whole nother network for your guest. So this SSID, it can also be hidden, but it's really easy to see hidden SSIDs with just a simple program. And let me show you what that looks like. Kind of jumping into security. But we see here this application called Insider. So this application Insider can show us a lot. And it's free. It's by MetaGeek. You can see right here. And what this does is it uses our wireless NIC and shows us on this nice little graphical interface all the different SSIDs and wireless networks, and you see their signal strength. And you can see here like this hidden SSID that may be being transmitted on one of the radios in my network, or radios, antennas, but you can still see it, and you can see it here at this actual spectrum analysis like pane right here, going over the 2.4 gigahertz spectrum. Okay, some more terminology. So the distribution system. So the distribution system or distributed network just describes the backbone infrastructure or backbone wired infrastructure. So what do we mean by this? So essentially a distribution system is going to be where your access points connect back to the wired infrastructure. And that distributed network or distribution system is how we reach, you guessed it, the internet. So what this allows, however, is roaming, because when we actually game plan our network and we do a wireless network plan and deployment, we plan to use our wired infrastructure to connect access points all throughout our geographic area or our office. And that's going to allow these access points to all talk to each other. And essentially, they're going to talk to a wireless LAN controller, but this distributed network is what gives us that infrastructure, that backbone to allow roaming and to allow users to have a seamless experience between access points. You see this bullet down here, it said distribution systems can be wired or wireless. What they mean by that is this entire thing would be the distribution system, the convergence or the interoperability of wireless and wired networks. But really, when you're talking industry and someone says the distributed network or the distribution system, we're really talking about this wired infrastructure. Some people will include access points in that, and we can look up definitions, and they'll say, oh, and then the wireless points or wireless devices are this. It just depends how you look at it and who you talk to and how you describe it. I've seen both, but when I hear distribution system or network, I'm automatically thinking, okay, yeah, our layer 2, layer 3 wired infrastructure that access points are using to allow a seamless system. But then you say a distribution system allows roaming, and like, okay, that means that these access points would be a part of that. For the exam, my best bet, safe bet, is to say distribution system. They're talking about this wired network. All right, and then a controller. So what is a controller in our wireless networks? So a controller is going to be that central focal point of that brain and what we call a lightweight deployment or lightweight APs. So what this controller is going to do is it's going to manage all the data and the flow, the switching, and the routing for all of our Wi-Fi enabled devices. So sometimes it's referred to as split MAC, because essentially this access point, instead of doing any switching of its own at the layer 2, its sole purpose is just to be that RF emitter that connects to Wi-Fi enabled devices and then sends all traffic, and I mean all traffic, back to the wireless LAN controller over something called a CAP-WAP tunnel that gets built from AP through our distributed network or system back to the wireless LAN controller. They build these CAP-WAP tunnels. There's two. There's a control tunnel and a data CAP-WAP tunnel that we're going to go over. And when our users connect to this access point, their frames, their packets, everything is getting switched and routed through the WLC, the wireless LAN controller. This controller also configures the access points. It sends the profiles. It configures all the different wireless LANs, all the different SSIDs, what kind of encryption it's going to use. So at the access point, it's still doing that wireless encryption, right? It's still the workhorse for like the WPA2 AES encryption or WPA3. That's still happening right here, but it's getting that configuration from the controller. And then this controller provides that centralized monitoring and control over your entire wireless network. And depending on how you deploy this, that controller could be completely integrated into the access point, meaning like we have like a switch that we can embed a controller into, and it can also put some antennas that is wireless. And then as we expand, we can implement some more access points that still talk back to this all-in-one system. You don't see that a lot. Typically what you see here is things like this, these wireless LAN controllers right here. So this little small guy here, wireless LAN controller, those are ones that are really sold for labs a lot. It's pretty cool. It's easy to deploy. It's easy to get you used to the wireless LAN controller GUI. However, it's not very robust. As you can see here, it's even got PoE ports. So maybe this could be used in like small business where you just connect this off to your modem and then you send it, right? You connect your 2 VoIP phones to those PoE ports and you're good to go. Or even your access point and then 1 VoIP phone or whatever the case may be, right? And then these up here, the newer models of wireless LAN controllers. These are going to be our more robust ones, the ones that you're probably going to deploy in what we call a cluster or high availability. And these are going to have extra ports on them, like the service port, management port. And then this is going to give you out-of-band management, the service port. And then the management port's how we're going to, manage the wireless LAN controller, how we're going to actually get to its web GUI. And just to show you what that looks like, the web GUI, I believe I still have it up right here. Let me clear this off. So again, if you watched the intro video, I think I went into this. This is what a Cisco's wireless LAN controller GUI looks like. This is like what the 3500, 2500 series will look like. And then the Cisco 9800 series, which is kind of part of that embedded access point. It's going to look a little different, but essentially the same. Here I can manage all my APs. I can configure a wireless network. I can set up security. You can pretty much, you do everything from here. You no longer have to ever SSH into the access point if this is all working correctly. And then let me bring my face back into this. Let me show you again if you missed it. If you missed it on the intro, let me show you again. This is what an access point will look like. This is that 2500 series. Real small. You can see there's no service port on here, just a console for when you do the CLI initialization. And then 4 ports that you probably want to configure maybe an Ether channel on or leave just 2 open for whatever the case may be. And this is where you're going to configure your management IP so you can actually get into the GUI. And then I got one more to show you. This big boy. So this is the 5500 series. As you can see here, this actually does. So it has a service port up here. It has your console right here. And then it has 8 ports with SFP, so we can actually do fiber into here. And this is going to be our robust wireless LAN controller. It's an older model. It's not the newest ones, the 5520s, I think, 5508s. But it's still really good. It's definitely end of life. But this is what a big wireless LAN controller that you would probably deploy in a cluster with that high availability. This is what it looks like. All right, so those are controllers. Let's get back to this section. And we just got a few more slides before we finish up Wi-Fi terminology. Okay, and then ESS, sorry about that. And then ESS and roaming. So this is what I was telling you before, like when we do that lightweight deployment, and then we have all of our access points advertising the same SSID, and they're enabling some 802.11 functions that got configured from the controller, where it's basically an interconnected group of BSSs, basic service sets, that allow you to have what's called ESS, extended service set. So we combine all the BSSs of these access points to create an ESS, and then our BSA, basic service area, expands. See how that can all work together, all these terms? And this is done through that distributed system. So we'll have a wireless LAN controller over here, or maybe we'll have 2, and they're connected to, and they're controlling all these access points. We could have thousands of access points that all give us roaming capabilities, so that when we're moving from space to space and we get out of range from this particular access point, as long as we're in range here, we don't have to cut off and then cut back on, disconnect, reconnect. We can just have that seamless roaming. So it extends our coverage, right? And it's much better than just single BSSs that we have to keep disconnecting and rejoining, disassociating to. Okay, so that's going to be it for this video. We're going over Wi-Fi terminology. I hope everyone learned something. I hope it wasn't too boring. This is kind of like the beginnings of wireless, kind of just like, you know, just drags on. You kind of get heavy eyes. But it's something we have to know. If we're going to start configuring wireless LAN networks, we got to know our fundamentals. So I want to thank you guys for viewing. And again, stay tuned for our next video. And if you ever are interested in some live virtual training or in-person boot camps for your unit or organization, hit that link below. Thank you.